That's me. My name is Artem. I'm working as a solution architect in EPAM systems, working for about like 10 years, 7 years in automation and like about 5 years in performance analysis. And like work with a different client, with a different problems. Most of them were in the field of a performance, like lately start working in the field of a security automation. And now we're gonna talk about continuous tests, right? That's sort of buzzword. Everyone's saying like continuous testing, whatever stuff we need to do. It's like we test continuously, we do stuff pretty often. Right, we commit, we do functional testing, and we test it in Jenkins. Are we continuous already? Or like we're missing something? Just in a short, the continuous testing is like subset of a different testing activities, sorry for that, like the stand, which include the static analysis, which is obvious, unit testing, which will fall back to developers, right? Then what come to QEs and DevOps is like integration, functional, security, performance, chaos testing, which is like nowadays is a bit more important in the field of all of this cloudy stuff and digital transformation and all of that thing that we're selling. And last but not least is synthetic monitoring. Who from you are doing synthetic monitoring on their projects? That's a good question. Actually, very good, but still question. Synthetic monitoring is sort of functional tests which are running 24/7 and verify that your system is operational. The goal of this exercise is preventively identify functional issue in your system, right, and they are run against the production. No. When you use Google Analytics, this means that you track how your users use your system. But that's the idea, right? You need to identify your problems before your user do. That's the thing, right? And with the functional test, you can do that, right? And with the Google Analytics, you can't, because like your users will kind of find something interesting. Go for it. Health checks, that's a good thing, right? How deep you can get with your health check? How deep to the business logic of your application you can get with the health checks? Not very deep, right? So like you can technically do a curl of a login page and say like, hey, I'm kind of fine. I have a static HTML rendered. That's really not what it's all about. It's kind of going deeper, going through the functionality, find the issues which deployment may fix. And that's an interesting thing, why we actually need to do that. Right, like later in the days, technically last year, Google done a research, right, and they say like, okay, technically it's called DORA, right, but was this DevOps Research and Assessment Organization, and it was acquired by Google Cloud now. Right, and what they're saying, they're saying pretty simple thing, right? That now, the high performance, let's do not look at the elites, right? Now, high performance doing the deployment from the code, right, from the actual merge request to a production deployment between 1 day and 1 week, right? And like 1 week is pretty okay, like most of us can do this in 1 week. But what about 1 day? Right, like that's the lead time. That's what's more interesting, right? Because that's where we are. That's where we're supposed to be. And like, if we can take a look at it, what? Like, okay, 1 day. Who does that? Like, can you make up a percentage of the companies who are actually like somewhere here in high performance and elite performance? Like the percentage, like the number. How many? Like, I mean the percentage of the companies on the market who is doing that kind of fast deployments. Less than 5%. Less than 1%. Any other number? 0.000, close to 50, actually. That's according to Google Cloud, right? I'm pretty small to kind of adopt these numbers. And they say, right, that, like, in this case, is close to 50%. Technically, the elite group is a part of high performance, so it's technically the overall of that is 48, right? I just moved this circle to kind of look fancy, right? And like, in comparison, and that's actually triggers some thoughts in my mind. From the point where we are now, like when we are deploying, like, and doing this stuff pretty loosely, not really concentrating on the speed, on that acceptance speed and all of that, like to the point where like 50% of a market are, that sounds like a long way, and like, and that's actually why I started thinking through, like how we need to apply continuous testing versus how we're applying it now, right? How we need to make decisions on like how good our project is, like how actually good we are, how like is it ready to be deployed, is it like good or not, and one other important thing on the previous slide, is this number, right? This number actually means like what percentage of deployments are actually need to be rolled back, right? And this number means like how fast they are actually rolled back. Very simple, very straightforward. Like you're deploying, you're saying within 1 hour, like testing all your stuff, saying you're good to go, you're deploying and you're kind of able to roll back like pretty fast. Like, and that's the question, what they do to achieve that. And then there are a couple of other numbers, which is actually, that's a percentage of manual operations. They calculated actually how much time they spent on each of that manual operations, right? Basically, which is like in a real world, it means like what percent of a job is not automated, right? And not only not automated, but kind of also consumes time. Actually, that's more of a right word, which actually means like that I'm more interested in, why it's not clicking? Oh, it's not clicking, okay. I'm more interested in this column, right, the testing. Because like I'm from testing, and I'm worried about the testing, and I'm worried, like I'm less worried about like how fast we will deploy after we test, but what I'm worrying about is how fast we can make a decision that we're ready to go. Right? And there are some interesting traction there that the low performance doing less of a manual work than the medium performance, but that's pretty, like, there is an explanation for that. I can give it like later on when we will go out of the topic, because not the focus. But the right thing, right, is 10%, 20%. That's the time for the manual operation. The rest is automated, right? So the decision, most of the decisions are actually automated. And like how they do that. And that's like one of the stories which we start with in order to kind of bring some sort of at least try to bring some level of that automation to our like daily routines. As most of the people who do performance testing, we start with the snake of performance testing. Right, the performance testing snake. Pretty straightforward, like easy to go. You have some either API or UI on one side, then you have some load generator wherever it is, then you have some influx. Everyone saw that, right? Like, okay, we can run that stuff in a CI. Everyone can run that stuff in a CI, right? But that's probably not enough, because like even running that stuff on a CI would not actually helping us to answer a simple question: how good we are. Right, we kind of see numbers, right? And we still need a person who will analyze those numbers. Right, we understand like we are here or there, or like we are getting a bare set of numbers. Right, and we start seeing like, how can we say actually automatically how good we are? Right, like that's a simple question. Everyone can run on a CI. That's all kind of working. That's all fine. But are we actually green, yellow, or red? Right, we came up with a simple set of rules The capacity is acceptable. Acceptable means like measurable versus the a baseline, and it's kind of not worse than a baseline. The response time is accessible against the pretty same stuff. We have a baseline and measuring against the baseline, and the functional rate is less than 1%. That's an interesting one. Because like in performance tests, you always have pretty high amount of the failures, right? And some of the failures may be related to environment is not ready or something like that. And like, we need to understand which are actually the right one, right? We've kind of started using report portal for the performance tests. And Dima was saying, no, that's not gonna work. Right, Dima, usually when we come to him and saying, hey, we will use your report portal for this thing, he's, nah, no way you can do that. We have those AI, machine learning and stuff. I'm kind of, okay, we can make it. Right, we started using the report portal for identifying the issues, like if using that machine learning to identify it, either it's a bug or it's some kind of flakiness, right? And the Grafana, that's important thing. We customized Grafana pretty much in order to be able, technically the influx is also there because it's kind of Grafana without influx is nothing, right? Customize it pretty heavily to be able to configure the thresholds, and more importantly to be able to set a baseline, which can be part of an automatic assessments. I believe the automatic assessment of the performance of a system. Then our system, I would say, right? The snake of a performance start looking more like a leaf of a performance. Right, which kind of, we included the report portal, we included Jenkins, and data from Influx and report portal goes to Jenkins, and through some sort of analytics, and help you to define is actually your build is success or failed. Right, like you can say if it's good or not. I will show you how it looks in real life. Right, and then like what's next? That's pretty good, right? We can kind of survive that. But then the next question appears, right? The performance reports, everyone, literally everyone, like once you're doing the performance, everyone wants some sort of a report from you. Right, and the report is very hard routines, it consumes kind of a lot of your time. I was like, how to avoid doing that? We don't want to create reports whatsoever, not like never. We've done pretty simple thing, again. Right, we've started thinking on the what we can do to avoid that, right? And we kind of like if Sorgi automated the creation of a test cases, we kind of automated creation of a performance reports and delivered a couple of different types of reports. Right, we actually created the service, right, which called Vision. And this Vision service actually do all the analytics from those bows. Right, and then notify everyone who is interested in a few different ways. So developers get their Slack notifications. Let's start looking like that, by the way. The developers start getting their Slack notifications to do not go anywhere else, to kind of be fast. Managers start getting email notifications, which kind of show them trend, how the deviation go, all of that managerial, very important stuff. Right, and last but not least, we transferred performance failures not in a failures like, not in a somewhere Jenkins failures. We transferred them directly to Jira tickets. No report portal, no one knows that it exists. Like technically they do because they pay for the instance it deployed. Right, but it's kind of, at the end of the day, no one goes there because like everyone's getting reports in Jira. That sounds pretty cool, right? We're like, okay, now we are done. Now we are done, we've done pretty cool system. And like okay, yeah, you're done pretty cool system. What's next? Give like 20 different projects and repeat. We're like, oh, that's sounds like a bit of a challenge. And like they repeat an ACI, like that should be automated as hell. We're like, okay. That's kind of, at the end of the day, right, you kind of need to scale both ways, like up and down. You technically can do 20 projects, you can do even 30 projects, even a million projects if you have like a static infrastructure, right? It stays forever, but it costs you a fortune. So like you kind of Then we start thinking, okay, let's go, let's do simple DevOps-ish stuff, right? CloudFormation and Docker. Like the Docker was all the way through, right? It's kind of the CloudFormation is joined there, and the Docker is more like closer to that icon and that topic. So basically there was a CloudFormation. CloudFormation that helps you to deploy whatever infrastructure you need, and then run some sort of a Dockers there, and kind of make it a bit more elastic. Having that exercise, we kind of get to this, and like the API is already not a single API, but like a million of different APIs. Right, we get to something like that. And we've done that. That was a success of a single project. And like, as Sorgi mentioned, that we've tried it on a single project, and the single project is kind of not really a scalable solution, right? We kind of need to take that thing, go somewhere else, and the interesting thing about the NDAs, right, and all of that law kind of stuff, that you can't actually take that code to go anywhere else. So like, as you've deployed that for a single account, and then it needs to stay there. So the only thing you can take out of there is kind of take a part of your brain and kind of re-implement. We kind of, okay, at least we know how to do that, and we may avoid a couple of mistakes. Right? Then was a couple of sleepless nights, right? We've kind of, that's a piece of our brain that we take with us, right? That we need to kind of do some sort of a platform that could be lift and shifted, easily deployed, right? Because to configure all of that is like half a year of a time to kind of go through that experiments and go through that all things and to make it kind of work. And like, we've taken the brain, and we start doing that. Is it here yet? Yeah. And we started doing that like an open source project. Very simple, very straightforward, nothing very complicated. Just taking the components that we use one by one and just like throwing them to an open source. Rewriting, making all that things. And the first three things that is already there, and I will demonstrate that. It's the JMeter container, Gatling container, and Lighthouse. Right, the Lighthouse for the UI performance, pretty like nice thing, right? I would say. Like, but that's also like smallish, right? Everyone can run. We all know that everyone can run performance tests in the CI. The important thing there that we've kind of done, that's in the beta infrastructure kind of pieces for scaling. Right, to kind of be able to run that distributed loads with the huge amount of load generators and all that stuff. Then we have another thing which brings value is dynamic and static security testing containers, right, which actually give you an ability to run your code through the security scans, report some sort of results, get some good stuff. But that's like what you do delivery from, right? That's what is called like intelligence, some sort of, right? But the other important thing, we also put in an open source all the dashboards we have for the Grafana, all the schemas we have for the influx, and most importantly, script, kind of currently only one, more to come, right? Which actually allows you to install all of that in 2.3 minutes on Amazon, right? Because that's a good network. It very depends on network. 2.3 minutes on Amazon on a bare Ubuntu machine. So in the 2.3 minutes, you have all of that deployed with Jenkins, with configured Grafana, with configured Influx, with demo jobs, which is able to run Lighthouse, Gatling, and JMeter, with all the dashboards configured, and you can just play with it and to understand if you like it or not before you kind of go into use it. And the last experiment I was doing, now it's time to show something. I have videos, not like Dima trying to complain on the internet. Give me a second. Oh no, don't reopen. I have videos, but I have a logging player. Haha! I also have an excuse. Again. Is it there yet? Yeah. Yes. Where is my mouse? I lost my pointer. Here it is. No, not there. Oh, here it is. The mouse pointer. Well, it's technically called the pointer. That's not interesting. Go from it. So yeah, that's the installation piece. I speed it up just a bit. Because like the launching of an instance, everyone saw how to launch an instance in Amazon. It's pretty straightforward procedure. And that's done for humans, not like for those who knows how to use the CLI, right? So and main purpose of that is to demonstrate to get at least some understanding of a security groups that you need to have opened, because like we need to have it opened for Redis, which is used for distributed management. We need to have, apart from Redis, we need to, and like the distributed work management is working through the distributed job queue, which is built on top of a salary, which is a basic Python thing for working with the distributed queues, right? So while instance is starting, I'm trying to find my SSH key. Right. The other thing, you need to have ports open for influx, because like to influx you will need to kind of send the results in a two different way. One is from Gatling. Gatling is not using the standard influx port. Yeah, that's an installation. You're just copying the freaking line, pasting it to your clean machine, right? And you're done. Now, like, you need to input two things. One is the amount of workers, which called like processes for execution of a jobs you want to have on this machine, right? But that's mostly for the distributed load. And another one is a public DNS, because like we kind of need to put that public DNS in a couple of places, and the public DNS is not always available from the point where are you installing the system. Now that's very cool console, but that's it. That's all what you need to do. Now you just go in the same URL and you have 3 jobs. But Jenkins is not a super awesome thing, and when you will, it's super awesome, but it's kind of have a one bug. And if you will start the job, it will fail. If you will start the job right away, it will fail, because Jenkins do not think that you have public URL configured. Like I have some, but that's a good one, right? Because like when you go there, you have this Jenkins URL configured, but you need to click save to kind of Jenkins know that you actually, are you sure that that's your URL? No way. So yeah, and that's installation done. Installation done pretty simply, single command, then a couple of clicks in Jenkins. But that's the tool we use for a living. And now the UI test. So for the UI test, I just demonstrated a scenario. We're now working on the authenticated scans, right? On authenticated tests. Because like we have a code for that, but it's not user friendly. So the test is very simple. We are doing Google, we're searching a couple of queries, then we are doing Yahoo, I believe Yahoo. Yahoo? Why I'm so slow? But okay, yeah, Yahoo. So then we are doing Yahoo. Our target is pretty simple. Our target is to record all of that, how much time we've had for the loading of a page, how much time we actually got for this first byte, last byte, rendering time, what we can improve. We can want to see the waterfall, something similar what Christian was showing today with all of that resource allocation and stuff, right? So that's the Grafana. Once the test is started, I was doing something. Why I have so many notifications? That happens. Sorry for that. Once the test is started, we the results are reported in real time, right? So you technically can configure all the alerts on Grafana or wherever else you want to, right? But the results are reported in real. Oh, that's the glitch of Grafana was, because all the dashboards is not available on the screen in the first place, so you kind of need to go. Yeah, and then you're seeing this, which is actually the pages you opened with some sort of a breakdown on different stages of a page load. And that's like looks fancy, and for most of the people it's enough, right? But kind of for most of the people, I mean those who asks for reports, mostly managers, right? And for the engineers, when you're trying to understand why it actually took so slow, right, you kind of need to get more information. And when I'm saying more information, I mean like those cool table, like on there, right, when you can click on the whatever percentile you want and have detailed information about how the page was actually loading with all that waterfallish stuff. That's actually open source JavaScript someone created and we stole it. Not actually stole, open source is taken. Yeah. The page is kind of, the test is going. Apart from that, if you have the report portal link configured, with the report portal, you will have this all information loaded to report portal, but it's like in our poor life, we have that stored in the Jenkins, which is like the screenshot, which kind of say you that you actually, we actually were on that page. And last but not least is, yeah, that's the Lighthouse report. The Lighthouse report is the Google Lighthouse. That's, I believe, some ClickHouse or wherever this stuff is using that. Right, like all those speed test IO, all of that built on top of a Lighthouse, to some extent, right? And that's, we kind of getting that for free and uploading it to, and we able to upload that to a couple of sources. One of them is Report Portal, another one is Jira, right? But that's where we get. Any questions so far? No? Okay, that's fine. I can have a third one. Quick time up. That's it. That's the third video. That's that sample Gatling test that's actually uploaded, right? The sample Gatling test is actually, we are using the challenge fluid.io. By some reason, they created this challenge site for the performance testers, which kind of gives you at least some sort of a request responses with the processing of a form results, and some like you need to do something smart there in terms of like you really need to pick the higher number and things like that. I'm just demonstrating what will be tested, right? That's easy, just a click, then copy token, paste token. So that's all contained in this demo script, right? And we kind of use those demo script mostly to show the capacity of a reporting. Because like the most important and most like valuable thing for us in all of that platform is the reporting, right? And the way we process reports. Because in order to do that, we kind of created that extended listener for JMeter, enhanced Gatling a bit, in order to be able to analyze and get and actually get that valid data we need from the, yeah, that's, I don't know if you saw Grafana. That's like our Grafana. That's pretty fancy table where you can see the detailed information about the test. Then I'm saying that the thresholds on top, right, is a sort of dynamic when you're choosing the value that's just behind those males. Right, when you're choosing the values, you can modify the colors, which is just a cool feature. Right? Then all the data is here is dynamic, uploaded in real time. You can modify the aggregation points just to see the changes like in data when you have, that's how aggregation works. You start seeing maximum, for example, throughput and an average throughput which you're getting. That's some sort of, may be a bit more valuable than the regular charts for the performance analysts. Right, and that's the data you're getting during the test execution. The important piece is the data that you're getting, like when you have at least 2 tests executed, right? Because like at the end of the day, not only the like in order to be able to compare build to build and say is it better or worse, you need at least 2 points, right? And when you have at least 2 points, you also like, yeah, that's it. That's the comparison sort of dashboard, right? Which is then wrapped by kind of some functions to be able to make some sort of decisions, but that's a comparison dashboards where you can see the difference between two different tests made, some sort of information of how each and every individual call is, how every individual call is different, and most importantly, you have a functionality to set the particular build as a baseline, right? Because like the baseline, apart from the thresholds in the performance analysis, is like very important piece, because the thresholds is what you think your system should do, right? And the baseline in this sense is what your system actually can do. So you can compare your results versus something you want to be, right? But in real life, in order to be in order to be able to deliver fast, you need to compare from the point where you were and be at least not worse than that, right? So that's why that's why I think that functionality of marking as a baseline is very important. Where is my slides? They going somewhere. Slides, give me slides. Probably somewhere here. Oop. Yay. So yeah, we published all of that on the GitHub, right? You can go there and grab there. All the latest and greatest every time built and published to a Docker Hub, right? It's we have pretty intensive work there happening. The email notification, automated decision making, and the Slack notification expected to be done at the end of next month, right? Because we need to pass through the testing stage there. The distributed, the system for the distributed load currently have a couple of glitches. It's working, but you actually can't terminate the job. And that's also what we're working on. But at the end of the day, the whole platform is tested already on more than 5 projects, not one like a Sergey's, but like 5 real production projects with the 5 different accounts. And like one of that accounts have like about 20 different projects in it, right? The second one is the life science, which have 2 different projects in it, and they use that kind of platform. And we have a couple of smallish ones, like a single project, single thing. So, any questions, concerns? Glad to answer. Yes?
Thank you very much. Very interesting. I have a question.
Go for it.
3 questions. First of all, are you planning to support any other platform rather than Amazon? Maybe
Yes.
Google Cloud?
Yes, everything.
Okay.
But after Amazon, our plan is to use to do a Kubernetes. Okay. We actually, after we do this, right? And under this, we'll do full flavor this deployment and run with eliminating the stupid things like you can't cancel the distributed load test, right? Once we're done with this, our next step is Kubernetes.
Okay, thank you. So next question regarding execution time of performance testing. So what is actual numbers, in time? How many time is required to run performance test and do performance analysis for build?
Oh, the performance analysis is like the seconds, right? The performance analysis are seconds, in automated way, right?
Okay.
The manual may require some time during the root cause analysis, but how much time it's required to run the test? I would say like that. When we're starting, when we're deploying that, right? Like deploying, deploying and onboarding the first project, and under onboarding, creating the test and running the first baselining, right, we take a week.
Okay.
Then every other baseline is 3 days more, right, in order to be able to click that that's a baseline. And all other time, we just have it running every day.
Okay.
Every day.
So which kind of performance tests are you doing? You're doing volume testing, you're doing...
Very different. Like when we're doing the baselining, there is a standard thing, right? We're doing capacity, right? We're doing then responsiveness. We're doing then those different type of a baselining, volume, load, longevity. That's my favorite,
Okay.
That's my favorite. That shit runs for 2 days, right?
So test runs 2 days, am I
Yes.
right? Okay, and how, with these numbers, do you think you will able to achieve goals to be released in 1 day?
Yes.
How?
Because like fairly saying, I don't actually need to run all that thing for every drop, right?
Yeah, I agree with that.
Because like, and then when I need to run that thing for a particular drop, that's an important, right? I have a number in capacity, what was for like the number from last audit. For example, like 3,000 users, right? And in order to be run the 3,000 users test, you definitely need to have some kind of long ramp up or things like that. Your infrastructure need to be warmed up. There are a couple of tricks, right? We're running all the tests in parallel. That's one thing. I mean the functional performance security. And the other thing, we're warming up before we execute.
Okay.
We're warming up, then we execute the shorter period of time, same level of load, just to be sure that on the capacity we are not leaking.
Okay, got your tricks. Okay, and the last question is regarding report portal.
Yes.
What is the goal of report portal in your...
Why we are doing the report portal, right?
Yeah, why you are using report portal?
Oh, why I'm using the report portal? Because like I'm lazy enough to create the tickets by my own,
In Jira.
right? In Jira, like. And that fall back into all that reporting piece. So like what we do, we'll have the test run, right? We're kind of going through the results. We do the grouping, some sort of a grouping for the failures, right? Then we raise those failures in the report portal. Then in case the report portal marks that failure as a known bug, right, or the production bug, which do not have link to Jira, we have some sort of a secret source, yet another extension to the report portal, which create those tickets automatically in Jira in our predefined, I would say, format, which is like very different from the one which report portal used originally. And that's the answer.
Okay.
And cool thing, we use report portal API to get the Jira IDs in our reports to the management. You're saying this build, this failed because this, and this Jira issues. Done. Yes, I hate doing reports. I love robots to do a robot's job. Any other questions? No? No? Go for it.
Thank you very much. It all looks really impressive. I just wanted to wonder how difficult is it, how labor intensive is it to reconfigure the whole setting for, say, a new API or a new metric the team might want to see on the dashboard?
Good one. Like if the team can formalize the function, how to build that metrics, or build the query to influx to obtain that metric, right? That's the matter of a single query, right? And the single edit on the dashboard, right? Then, for example, there is something that never exists, something very specific that team want to calculate, and like no one actually record that metrics, but it's fairly saying can be calculated through some mathematical operations from either the whole result set or the particular with the particular request is easy, right? You're just doing that on the you're just doing that with again that query or some other type of a query. With the whole data set is a bit more complicated because like we have built in the comparison dashboards, the one that I showed you, right, when you're comparing to build. That is built on the results of a whole data set. And if you want to get yet another number there, you probably will need to write some sort of a piece of a Python code and kind of add to the processing mechanism of the whole data set. So not really complicated, but it's kind of, yeah, but some programming skills will be required. Because that's, again, like the orchestration and all that stuff is built on Python.
Cool. And scaling-wise, does the can
Limits?
the tool scale itself to like to increase the
You mean in
amount of load?
infrastructure?
Yeah.
Like it can scale on existing infrastructure, right? Scaling of the infrastructure is planned, but not there yet, right? So like in case of an Amazon, like it's not there yet, I mean in open source version, right? Because like from Amazon, it's fairly simple. There are multiple ways of doing that. For the Kubernetes, it's even easier, because on Kubernetes you actually can not think about the infrastructure portion. You just launching the pods and saying that infrastructure should be managed by someone else. But yeah, that's planned, but not there yet.
Cool. Thank you.
No problem. Any other questions? Oh, two. Good.
Thanks for your talk. And my question is your system supports any other storage except from InfluxDB?
Currently, no. But that's again, the idea of this whole system is you can take out any component and put any other component, right? Like it do not actually force you to use like the whole thing. You can use only a single thing. Right, and for example, in case you want to use all of that analytics which pre-built in the container, right? I mean in the performance container or like UI container, but you want this data to be sent not to Influx but to some other database or some other storage, right? There are tweaks need to be made definitely, right? But it's up to you.
And one more question. Is it open source?
Yes.
So I can just fork it and, for example, write some Terraform scripts to automate deployment of it? Oh,
Yes,
okay.
it's all there. It's all there. Wherever is on GitHub, right? We are trying to fix the bugs wherever we're finding, because like we are now in a phase of active adoptions. We are trying to support adopters as much as we can, right? And go for it.
Thanks.
Thank you for your talk. And how are you comparing baselines when a large part of application can be modified and replaced by more extended solution?
You mean like the major changes?
Yeah.
Right, the major changes. The major changes need to have an audit, we call it audit, right? An audit exercise run, right? So like when you have a major release with the huge pile of dirt coming like to your production, you need to have an audit, which means like running all of that tests to identify the baseline running in advance.
So
Then we will not be able.
Release, you're creating a new baseline and
Exactly.
you're starting a new history from it.
Yes. That's fairly saying, like currently on one of our production deployments, we support multiple baseline, right? It's there, but I don't like that idea. Right? And I really don't like the idea of multiple baseline for a single application, because that's very confusing, especially when you're trying to identify like which of the baselines are the actual baseline versus not really like the outdated. So yeah, answering your question, if you have the major release coming which replace a lot of functionality, you don't really have much of a choice rather than creating a new baseline or comparing it with an old baseline and matching like 30% of an API calls, because like the other 30% will be completely different, which is like very rare case, like based at least on my experience, like once in a lifetime thing.